So this example is a working example. X equals 8 minus 6t plus t squared. So this tells you where the object is at any moment in time. And let this be in meters. What now is the velocity at any moment in time? Well, that's the derivative, dx dt. And I use the following: x equals t to the power n. Then, as most of you should know, dx dt is then n times t to the power n minus 1. That's all I'm using. So the derivative of 8 is 0. I get here minus 6. I get here plus 2t. This would be in meters per second. And the acceleration, I have to take the derivative of the velocity. I get plus 2. So notice that the acceleration is constant in time. It's not changing, but the velocity is changing. Well, at time t equals 0, I'll start to probe a little bit. I want to get a feeling for what this object is doing. At time t equals 0, x is plus 8. The velocity is minus 6 meters per second, and the acceleration equals plus 2. I can also ask myself, at what time is x equals 0? What are the times that x is 0? Well, I have to solve this second order equation, which is something that you've all done in high school, and you will find that that's the case when the time is plus 2 and when the time is plus 4. Take the plus 2, that makes this 4. 4 plus 8 is 12, minus 6 times 2, that's 0. So you see the 2 works, and you check that the 4 also works. Just for my curiosity, when is the velocity 0? Oh, that's easy. That's when this equation is 0, so that's when t equals 3. What is at that moment the position? Oh, I substitute t equals 3 in here, and that gives me minus 1. X equals minus 1. So now I'm ready to plot x as a function of t. It's of course a parabola, and I use this information that we have just derived. So here comes my plot. Let this be increasing value of x. Let this be 8. And let this be minus 1. This is the time axis. I have a 0 here. And so I want to cover, let's say, about 6 seconds. So I have 1, 2, 3, 4, 5, 6. Now I'm going to use this information in order to give you a curve which is similar to that one, except this is a simple one. This is just a parabola. So I know that at time t equals 0, the object is at position 8. I know that x is 0. That x is 0 at the time 2 and at the time 4. So the object is here at this time and at this time. And I know that at time t equals 3, it is at position minus 1. So the object is here. And I also know that the velocity is 0. So we can check that. And so if I make this plot now, then we would get a curve that's sort of like this. And yes, indeed, notice the velocity here is 0. The angle alpha equals 0. The object starts out at t equals 0 with a negative velocity. You can see that. The object at t equals 0 is here. This is where the object is. I hope you realize that. The object is never here. This is the road. This is the one-dimensional track on which the object is sitting. The object is here, and it starts going in this direction. If it starts going in this direction, the velocity must be less than 0. And indeed it is. It's minus 6. But there is the acceleration, which is +2. It's in this direction. The acceleration says, I don't want you to go down. I want you to go up. Well, the velocity says, sorry, all I can do is slowly change, and that's what it's doing. It's slowly changing the velocity, and there comes a time that the velocity is 0. So the object goes down, the velocity changes, and when it is at position -1, it has come to a grinding halt, and now it is returning. This positive value of a is now increasing the velocity, and that's what you see. I therefore bet you a nickel that if you substitute in that equation t equals 4, that the velocity better be positive. It has changed from a minus sign to a plus sign because of this positive acceleration. I bet you a nickel. T equals 4. What is x? What is v? We want to know v. 8 minus 6 plus 2 meters per second. You see, physics works. V is now plus 2 meters per second. So all that information is in there, but I want you to be able to also digest it. Don't look at that curve as just some dumb parabola, some dumb curve. Try to imagine what is happening. And only then do you get some insight. Then you really begin to get it in your brains.